So, hello everyone. My name is Chip, and I'm here to talk about coding with AI. I know we changed the title last minute because I thought we could do something more fun for this audience. And okay, as well, I've been to a few talks here, and we have a lot of talk on kernels. So if you're here to learn about a torch compile, this is not the right session. So you probably want to go to other sessions. So this is more light, and I feel like coding with AI is still such a new topic that I feel like I'm still learning about it as well. And so I'm going to be asking some questions throughout the sessions. So actually, I don't really like the term vibe coding because I feel like too vibey, whereas I feel like it should be more systematic and more engineering focused. So I hope that we can talk about it as well. So before we start, I just want to ask, like, who here has been coding with AI? Ooh, almost everyone. So this morning, someone told me he's a hiring manager, and he told me that if he is interviewing a candidate for engineering, software engineering, and if this person has not experimented with AI coding, then he would consider that a red flag. So who here agrees that like is a red flag if a candidate has not experimented with AI coding? Okay, so a few. So actually, like this morning, before the talk, I just like tried to do it on online. And I don't tweet a lot, and I'm really afraid of this guy tweet, but because of you, I feel like I need to get data. So a lot of people, like, I think like half of people think it's a red flag, but like also like a lot of people think that is maybe too much to ask the candidate to vibe code. So actually a question that I've been asking people is just like, for companies, right? Because a lot of people already code with AI. How do we interview for it? Like, should we incorporate AI in the interview process? And someone told me that a lot of time, like because the next generation of AI coding tools is so much better than the previous generations, that AI coding interview end up being like a test of who stay more up to date with technologies. So I think it's an ongoing discussion. And if your company has successfully implemented AI coding interview, I would love to learn more, and I see like how to do it well. Okay, so we can just like give a quick intro of AI coding tool because you are so, I feel like a lot of people here are like very serious kernel engineers, so you're pretty very familiar with new technologies. So there are many different kind of like interface, right? I think like the first generation is like IDE-based interface, like when you have something like VS Code, and then you can like just write code in this in your editor. And then you have like CLI, the next generation. It's very common now, like Cloud Code, OpenAI Codex, like Gemini CLI. And I just found out that like Amazon has their own like queue as well. I'm not sure who's using it, but I feel like some people do like it. And also like this GitHub interface, which I'm pretty excited about. So the idea is that like you can like, maybe you have a PR, and then you can invite the AI like into the PR and can review and suggest comment. And of course, the last one is a web interface. When, for example, like you can like send, you can upload a screenshot of the website interface you want, and just ask it to like produce the website with the interface. So out of curiosity, who here prefer IDE-based? Almost everyone, wow. Who here prefer CLI? A few, like still a lot. And who here prefer GitHub? So I guess for web interface, let's see who's a brave soul. So we don't have enough front-end engineer here, I see. Yeah. So I actually did this with a company recently. So about like we poll about like 1,000 engineers, and this is the preference. Like almost everyone went for IDE. But interesting enough, I also did another one with my friends. So I made all my friends to go on Zoom and then made them do a Zoom poll. You might wonder what kind of friends I have, but yeah, I have the kind of friends. So this is a preference. And I do realize it's like the preferences actually change a lot with like how much exposure you have had with AI coding tool. And I think so when we started talking to this company, and they told me that, okay, I cannot take the result at face value, because it turns out the company has only adopted IDE-based coding tools. So a lot of the employees have not had experience with like CLI. So of course they cannot like have that preference. So I think like nowadays with AI coding tool, I don't think is a one tool. I see that the most productive people actually work across multiple interface. And actually, there's a book that I really like. It's called like the principle of least effort. So the idea is that whatever we do, we choose the things that take us like least effort to do so. And I do see the same workflow with like coding with AI. So we usually start with something that is like requires the least effort. So maybe like when you start out, right, you can start with like an agentic thing. Like, okay, we want to build something. Let's just throw into the like write a prompt, ask the agent, like maybe like Cloud Code or like Codex, to just do it end to end. And when it fails, so we started something like maybe higher effort, maybe we can go into the code base, start fixing it ourselves. So I think like we should like start like moving more and more toward like least effort, and the better AI coding tools are becoming. So we see that people going more of like more autonomous tooling. So I think like productivity measurement, I feel like with this crowd is probably not a great. So one thing is like I work quite a bit with companies nowadays, because like once a company spend a lot of money adapting AI toolings, then executives start looking at like the usage, and they were like, okay, we pay so much money, but we don't see a lot of people using it. So like, what is the case? Like executive might think, like, how can I justify to the CEO or the board that this is worthwhile? So people are looking into a lot of like ways to like measure productivity, and I would love to hear from you like, how do you measure, like if you ask individual, a lot of people say yes, we feel more productive, but like how do you measure it as like return on investment to show it to people? And I think that traditionally we have productivity measurement like engineering time and lines of code. And of course, it is not ideal, because like one thing with engineering time is that I don't really care if things takes longer if I don't have to pay attention to it, right? So I think of it as like the mental energy. So let's see, just like if something can go from end to end, right? I can just put it there, maybe it can take like an hour, but then if I can just go to bed and wake up and I have like 20 of them or like 1,000 of them, and I can just see the results the next day, so it's not that crazy anymore. So I think that engineering time is a very bad metric for that. And another one is like for the lines of code, like AI is really good at like producing code, but I don't think it's a good measurement anymore, because we need to care about like how does this translate to like actual tasks done. And I think it's a long discussion, and I would love to hear from you all, like how do you measure that? So when I think about like energy time, we think about mental energy. What I think about is a measure of autonomy, right? Like how do we measure like how autonomous AI coding tools are? And this is, I borrow the idea from Graham Newbeck. So he's a professor and he's a creator of this very cool tool, like Own Hands. So the idea borrows from like self-driving car. So we have different level of like automations. So at the first level, right, like it's like auto-completion. It's like you still write code, but then you can accept or like reject auto-completions, like suggestions from the AI. At the next level is like partial automations. Like you can only automate like certain very small subset of tasks. Like maybe you can write documentations for like a functions, or you can like very, very small, like feature fix or bug fix. And I think like humans still need to review a lot of these tasks. And the next level is like conditional automations. It's like you can full automation on like very, very, like full automation on a lot more tasks. For example, like a new, like build the entire app end to end. And the next one is high automations, and it can basically do almost everything except for specific code base. For example, like legacy Oracle code base, or some like very strange language that like you don't see a lot. Maybe like some CUDA optimization could be considered one specific code base. And of course, the next level is full automation. So I think like, I imagine it's like most of the tools nowadays are like between level 2 and 1 and 3. I don't think that we're at 4 yet, but I see that we're getting there very soon. So one question I have is just like, how do we measure automations, right? Like how do you, so like there's different level of automations, and like how do we measure it? And I think the idea is that we need to know how good AI is, so that we can assign the right task to it. Because like just like a manager, right? I don't think you can assign a very complex task to an intern and see they fail. You need to be able to know what is the intern capable of, so that we can assign the correct level of complexity to that. So I was thinking about one thing I thought about is like interruption rate. So you think about like self-driving car, like you can let the car just drive. But then how often do you have to like jump out and like, no, change the action, do not do this, right? So I feel like if you can just let the car drive maybe like 100,000 of miles for interruptions, then you can have a much higher confidence than you have to interrupt it like every like mile or every 10 miles. So I think about that in the coding workflow. So I was like doing it, and I was like talking about interruption rate, and some people that told me that I should start adapting it. So for example, here is a blog post from my CEO of Continued Dev. So we're talking about like in the past when we do like delivery. Pushing code to productions, one thing we measure is the build time, like how fast we can build and deploy things. And the faster we can do this, then the more efficient that our continued delivery is gonna be. And you think of it as similar to like writing with code. Like the longer we can stretch out the interruption rate, like the lower interruption rate, then it's more confident we can have AI tooling, and the more mental energy you can spare to do other stuff. So like this, I do think it's like very important to like reduce interruption rate, because one thing is that we talk about less mental energy. The other is to increase the higher potential for like sub-agents. So are you familiar with like the sub-agents or like the task when you have a coding agent is spin off like some tasks that run in parallel? And so when I was reading the system prompt for this like task or like sub-agent, and one thing that's interesting that stood out to me is that like because humans cannot interrupt the task, right? Now you can interrupt the main workflow, but you cannot interrupt the sub-agent. So like it had to write and only spin off tasks when it has a high confidence of being to complete without human interruptions. So like if you can reduce human interruptions, then it allows the agent to like spin off more tasks of more complexity to reduce to be more efficient. Of course, it can reduce the context load for model. So I know that we have like model with very high long context length, but like context length is different from like context efficiency. So we're doing a lot of like benchmark or long context. For example, like actually I'm working with a publisher right now to like using AI to translate a book from like a language to another. And even though people say that translation is a solved task, right? But like for something as long as a book, it still has a lot of issue. For example, like if you translate a name to like a specific character, like in a language, right? Like if you translate in that way in the first chapter, maybe by chapter 30, you want it to stay the same. And we have so many issues of consistency. So yeah, and a book is not even that long, right? Like 100,000 words. So like it's way, way smaller than like 1 million or 10 million token. So it's the same thing with coding. Like the longer the code base, we see the less efficient, or like sometimes it forgets the function name and stuff. We can go into some of the error analysis for it later. So I do think that's like with the every time you interrupt, you create more context for you to remember. So like if you can just like get it autonomously, run longer, low interruption rate, then we actually can get the AI coding tools to be more efficient. So out of curiosity, what do you think is the current interruption rate for AI coding tool? Maybe something like, maybe the strongest coding agent that you can think of. 25%? 50%. Yeah, I think it's a tricky question because we think that I believe so. Like I have been asking a lot of people about it, and there's a big difference based on. So I actually have this tool called Sniffly Dev where we look up the Cloud Code logs and just see like people interruption rate, and this is what from multiple people, not just from me. And I see that it ranges from a very, very different type of like it can go from like 6% to like 50%, and it really depends on a few factors. So one thing is like the user background, right? So I see that people from like engineers versus non-engineers, and also like senior versus junior engineers. So like for engineer versus non-engineer, it's pretty obvious, right? Like for like non-engineers, for only a PM or like a technical manager. I shouldn't say technical manager are not engineers, okay, imagine someone who is not engineering background. Then you use AI to generate codes, and you're less likely to like interrupt because you maybe not understanding like what exact code is being written. So you just want to see the end result. But like for senior versus junior engineer, that's interesting. Who here thinks that senior engineers are more likely to interrupt AI coding agents? So who here thinks that junior engineers are more likely to interrupt? So I actually looked at it, and I found out that senior engineer actually are less likely to interrupt. And the reason is that because like senior engineers, or maybe it's not, of course, it's not a blanket statement, right? I think it's like a lot of time people who have a lot of experience writing code or like writing complex document or like design docs, they have a very clear understanding of what the end product should be. So they write very, very good prompt and like specs, and just give them like allow the agent to do more. And I think another pattern I have seen is that like a lot of people, they do like one pass of like writing the first specs, and then they produce the product, and then they look and say, okay, this is not quite what I want. And instead of trying to fix it, they're just like, okay, now that I know more of the specs, like what I want, right? So I rewrite the specs, and then I produce it again. And in the second time around, the interruption rate is a lot lower than the first time. Another thing is, of course, a task type. So, like, of course, like, there's a big thing, like, whether you work on, like, legacy code base or, like, a greenfield, like, you're starting a new code base from scratch and writing code. And, of course, people say that's, like, okay, it's a lot easier for AI to work on a fresh new code base rather than trying to work with existing code base. And another one is a tech stack. So, actually, I look at a different one from, like different languages, like Python, JavaScript, or, like, Rust. And another thing is, like, task complexity, which one is, like, more obvious because it's a more complex the task is, and the more likely is that humans will need to step in and stop it. So I want to ask a question of like, which language do you think AI coding agent could be the best at? Like, who here thinks JavaScript? Like, out of JavaScript and Python and Rust. So who here thinks is going to be the best at JavaScript? Okay. Who here thinks the best at Python? Whoa, we are on the Python crowd. And who here thinks the best at Rust? Few. So actually, first, during my interview, a lot of people are not Rust programmers. Like, finding them is pretty rare. And I guess I need to go to like some fancy conference somewhere. Sorry, this is a very fancy conference. So actually, like, people told me that Rust actually is really good at Rust. And the theory is that there are a lot of like bad JavaScript code on the internet. There are like moderately good Python code on the internet, but usually people who choose Rust are like pretty good engineers. And so Rust code on the internet is pretty good. So like it can produce very high quality, and also Rust, because of like it has a great compiler, so you can fix bugs as you go as well. So I was talking to one. I'm not sure like you have heard about one of these like engineers that's like Zuckerberg paying like crazy money for. I heard it create a lot of like internal strife within Meta, but I'm not gonna go into it. But yeah, so like I was talking to just like a very strong engineer, and he told me that he did experiment like let's say like if he generate like about 10,000 lines of code with Python versus 10,000 lines of code with Rust, and he told me that with Rust you can accept like 90% of it, whereas with Python I can accept like maybe like 40-50%. So I think for him it's like he fight Rust is a lot better with like generating like Rust, which is very counterintuitive. So one thing I also track is like the command complexity over time. So when we do code base, so code base I work with like AI coding agents are pretty complex, right? So you start quite small and then it grows. So like, I have a lot of like interacting back and forth, like adding like this feature or this feature. And one thing I track is like the numbers of every step per command, but the command I give it. So like, and how many steps that it takes to like completed over time. And naturally, as a code base grows bigger, right, it takes more steps for it to complete, because a lot of the time it takes spend searching, like looking for the right file, looking for the right functions, where to put the code, and like looking like where we have addressed the issue before. So like, it's very natural, if you look at a lot of this, you will see that increase upward. And for me, that is not okay. It's because of like every time like I wait for it to finish searching, right? Every time an extra step it take, the more likely it's gonna fail, and like the longer I have to wait, and like I'm very low patience. So I think I try to like keep it like flat. And there's one thing that like here's one project. So I was using it, and then I was start writing the backend in JavaScript. I don't understand why, but like it's the first reaction it did. So I changed it to like Python, and you can see that like it immediately got rid of a lot of code, and it also like become way more efficient when I each step. Another thing I did was that like I refer to a long code file. So like for me, when I try to work with a coding agent, my goal is try to keep it like very flat, because I wanted the time it takes to complete each task to be not too long. Because I don't think we have to face it like I can just leave it overnight and wake up to it yet. I still have to like still babysit it quite a bit. So one thing I also think about like how to reduce interruption rate, and I hope I have convinced you that interruption rate is like something important, or at least to me, because that is like stand between me being to just like wake up to something that's working versus like me having to just pay attention over time. And it's one thing I realized that I cannot multitask very well, because it's like I think like I can really like babysit maybe like 4 or 5 agents at the same time. I don't know how other people can do it, but like it's very easy to keep track of it, lose track of it. So if I don't have to babysit it, it can like spin up between like, I don't know, 20, 100. Whereas if I have to babysit it, I have to like, can only do only a few at a time. So for me, it's important. So of course, there are different levels of doing it. You can do it at a model level, like you can just build a model with better reasoning capabilities, or just better pre-trained capabilities. Another one is like tool developer, right? Like you can do like better agent, for example, with like better tool design, creating like better tools that you can use, or like with IL fine-tuning. I heard that's on the rage nowadays. Who here is actually doing IL fine-tuning? Okay, a few. Who here thinks that IL fine-tuning is important? A few. Okay. Wow, you really don't think IL fine-tuning is important? Wow. It's good feedback. But I do think another thing is like users, because it's very important to adapt our workflow to each agent, and it's something that takes time. And it's something I actually have issue with because there's a lot of papers such discussing developer productivity with AI coding tools. And a lot of times they conclude that no, it's not, like it makes developers feel more productive, but in reality it does not. And in a lot of these setups, they give developers very, very little time to get used to this coding tool. So I think that's like it's not fair, because it does, like with using any new tool, it needs a lot of back and forth to understand the agent and change the workflow to it. So I don't think that, so I do think it's not something that can happen overnight. And there's something that my friend told me that like, especially for like very experienced engineers, sometimes they get frustrated because like, okay, it takes way too much time to like get the agent to do what I want, so I would rather just do it myself. But the difference is that like, if you work with the agents, you force yourself to write the prompt, write really good specs, then it's a skill that you learn over time. You get better over time, and it's actually become less frustrating and more efficient. So when I talk about like human AI workflow, so usually we start with like planning, right? We write the specs, we see like what we want to achieve, and then we execute it. And like we write code, and then we verify, like we maybe run tests through it, maybe integration tests, like open it, localhost, and like look at the workflow. And then after that, we like go back to say, okay, we still need to fix stuff. And let's see like each step how it has changed with AI. So the first is like the planning, like writing specs and instructions. I don't think it has changed. Like humans, we still need to do that really well. And I think that people have been using AI, like asking you to generate specs. Yes, you can do it, but it's still you as a people who develop the app need to understand the users well and have very clear like what do you want, user requirement. So now like with vibe coding, it's like what I spend most of my time on is like writing a lot of this like specs and instructions. Another thing is like with like verify. So I'm going to go into verify more because I think the execute is where we offload to a lot of AI. I think like it's really depends, because for simple features, it's easy, right? You can, for example, if you want artists to create a website, you can look at the website. But like for more complicated features, like maybe like a banking transactions, and have to do a lot of like edge case testing, it's harder because it's not obvious. And of course, like the last one is like execute. So I do think it's like people do it less and less execution of code. Like people don't write code anymore, or at least like less and less of it. And people tell me that like, it's only. A lot of time people told me that they don't even look at the IDE anymore. Like a lot of times they code entirely in the terminal, and they fix it through like GitHub like PR review, and they don't go into like the IDE. So I'm very curious what the future of coding look like if we don't do it. And sometimes when I give this talk, people get very angry. They were like, "What? So am I just gonna be the person to review code? Like I became a software engineer so they can like build fun stuff, do fun stuff, but now I'm reduced as a person like code reviewers, right?" And I have never met a single person who enjoy code review. I don't know about you, but like people complain a lot about it. But I do think that if you think about a workflow, I was talking to like someone before here. It's just like if you think about it, it's a lot like a manager work, right? As you hire, you go up the corporate chain. You actually like do hands-on execution less and less, and you start like a lot of your work is in assigning tasks and reviewing the outcome from like people below you. So I do think just like we have become more and more of that. And I think somebody have a good way of putting it. It's just like AI coding is pushing us up the higher level of abstractions. So we don't do lower level anymore, but we do need to have a bigger pictures and understanding like how to assign tasks. So for me, I think of it as Like of course, the specs-driven development, analysis. Oh wait, I think I messed up the slide a little. But yeah, so like in Everflow, like of course we need to write a lot of specs, and some people call it like specs-driven development. Another one is like I do think it's like important for error analysis. If we can look at like the type of error that coding agent makes, then we can adapt our workflow to reduce this kind of errors. So for example, here's one of the graphs I look. So I just look at the errors that Cloud Code made, and I realized one thing is it's like the number one type of error I have is like content not found. So it's because in code base, like when you try to ask it to do something, so it was just like, okay, maybe I think that the code is in this file, or the function name is, or the chart is named like this, and then I try to search for it and it doesn't find it. So for it, I usually try to like do very well with structure my code base, so that it make it easier for it to find. So it's just like be very, very tyrannical about like about the coding structure. And another thing is just like I mentioned, is like pushing it up to like higher level abstractions. So we need to think about it holistically, like having bigger picture, understand the requirements, and just like be very clear about what we want. So yes, that's pretty much. Another thing is that like AI coding tools are like improving incredibly fast. So about a year ago, I did this experiment of like how many steps an AI agent can perform at once. And back then, like a lot of them cannot perform more than like 5 steps at a time reliably at a high success rate. And now I was looking at like my Cloud Code on my project, and you can see it's like the average like number of steps it takes is like 14, which is like incredibly high. And sometimes I attempt to go into like 100 of steps. Of course, step is not that not a perfect metric for it, because like some steps are easier to do, right? If you ask it to like for example browse websites, and it's a lot easier than like trying to like call the right functions. So not steps, like it's not good metric, but I think it's just like a proxy. But I think it's like improving incredibly fast. It's from like 5 steps a year ago, and now you can go to like 10, 15, and attempting like 100 steps. So yeah, it's moving very fast. So I'm at time here. Thank you so much, everyone. So the organizer have been very kind to like buy a bunch of books like engineering, and they're gonna have a giveaway, and they want me to tell you like at 3:20 today in the exhibit hall. Thank you so much, everyone.